I probably haven't seen much changing in the background.
I'm going to cover keystrokes today. Last time we talked about the mouse, and cover keystrokes. But before I do it, last class I picked a program that was, I think, too long because there wasn't enough board space to actually do it. So to have shown you how to do the thing was actually awkward. It just didn't, I didn't have enough room to do it. So what I did is, I thought about it a little bit, and I have a shorter program that demonstrates the same principles. There's something that happens in programming that you guys ought to get used to. This is not with the languages themselves, it's with how you program. Do you know what dead reckoning is? Dead reckoning is you have a home base, and you decide which way you're going, and by time you figure out how long you've been moving, and you figure out how far you are from home base, and you're moving in, and you figure out how far you were from that point by point. So it turns out that they've done research and they discovered that every insect, every animal, and us included, work with dead reckoning. That's how we work. That's anything that has a nest always finds its nest by using dead reckoning. They even found the mechanism in the animals that works. Dead reckoning has a problem. Is that if you estimate the distance, the time it takes wrong. Like for example, suppose you're trying to figure out how to get from here to that board there, and you start moving, and all of a sudden you run into a lake. Well, you got to go this way, you got to go that way, you got to go this way, you got to go around the lake somehow, which adds complexity to the thing. Whereas originally, you just looked over there and you saw the thing you wanted to get to, and you just started going towards it. It would have been easy had you been able to do that. It's exactly the same logic problem we have in programs. What happens is you start off writing a program, you say, I'm going to write a program that does that. But then what happens is when you start writing the program, you come up into these little logic problems that are actually a nuisance. They just all of a sudden appear just by trying to do the step-by-step process of getting to the end result. So the trouble with that is, this is a logic problem that permeates our entire society. If you wanted to be an engineer, for example, they're going to say, well, you have to learn algebra first. But algebra doesn't teach you engineering. It just teaches you the thing that prepares you for trig, that prepares you for Calc 1, for Calc 2, for this, for that, blah, blah, blah. But the point is, the first thing you learn isn't related, it's related in the end to the thing you're going to, but you don't know how. Because in other words, you can't, once you take algebra, you can't solve an engineering problem. You have nothing to work with yet. So basically, you've learned this thing, and most young people, being impetuous, say, well, what did I learn that for? What good is that? It really isn't any good to them, because they have learned something that they cannot use until they learn a little bit more and get up the hill. And that's the problem with programming. You start off programming, it's the same thing as dead reckoning. You start off, and if I were to demonstrate a program to you that was written correctly, I'd start writing the program up here, then I'd start putting things up here that wouldn't make any sense to what we're trying to do. They wouldn't make any sense that we need them. I'm going to find out we need them later, but I have a choice. I can either ignore those things and then go back and correct myself, or I can show them to you and say, we're going to need these later, in which case you're going to be sitting there looking, going, oh yeah, what do we need them for? So you see the problem with it. It's like the chicken and the egg. There's some things that are complicated are hard to teach because the things that you need to get the result done have to appear early on, but they make no sense until you actually get into the nitty-gritty of solving the problem. And that's going to happen to you in programming all the time, okay? So here's what I suggest to try to avert that problem as much as you can. When you start writing a program, supposing it's going to have 3 or 4 functions and it's going to do a bunch of stuff, what I suggest that you do is you write the first version, the one that just does one function, and test it to see if it does the thing that you want it to do, that first thing, and make sure it does that. Then you add the next section to it and make sure it does that. So then when you add the thing that you would have forgotten had you tried to do the whole thing at once, when you add it, it'll make sense. Oh yeah, I need this thing. And you know by that stage, I do need this thing now, and so you put that thing in. That way, the thing logically makes sense to you. Everything that you put down makes sense. It isn't like you're putting down stuff that you will need later because you don't know what that's going to be. And you only put that stuff down when you actually want to use the thing. Now, courses in logic, what they normally teach you is, about the major premise and the minor premise and the logical how to fit things together, how to get a solution with a deductive logic. But the truth is, the hardest part of logic is us. We have a problem. If you ask someone to solve something in geometry, especially those old Greeks, 20 Greeks will give you 20 different solutions. They're all using the same kind of logic, but they have different pathways to the answer, okay? And I think that's a critical thing that logicians don't pay a lot of attention to, is that individuals have their own worldview and their own strategy for solving stuff. But when it came to computer programming, we learned that pretty quickly, that you can have 3 companies producing the same product, but if you look behind the scenes, it looks entirely different. There's a thing called reverse engineering. Did you ever hear that before? The way reverse engineering works is, supposedly somebody writes a program that's really good, like an operating system or something, a video program or something. Well, you can't copy it because he's got a patent on it, okay? But what you can do is, you can hire somebody to go in and look at the code to see how it's done, and then to write an equivalent kind of code differently than this one. It does the same things. In other words, what does this do, what does this do, what does this do? And he writes a program that does those same things, but the code itself, he doesn't really copy. He doesn't have, he just looks at what the thing does. They have this thing called a black box. If you have a machine and you don't know how it works, you start doing stuff to it and see what it does. So everything you do to it, it does something. And you write all that stuff down. Then you say, can I make a machine that does that? You don't care what's inside of it. You just want to make a machine that makes the equivalent to that. That's the black box strategy. And that is how our real world works. Logic is logic. It's true, and it governs what we do. But behind the logic is how we approach the thing. And each individual does it differently. Once you know the rules, once you know the goal that you're trying to solve, use those rules to get to that goal. That you might go this way, another guy might go that way, might go different ways. So there almost is there's no such thing as a correct program. They're all different, but they all do the job. Even in the few programs we've written here, I've actually realized after I did them that there are several ways of doing them. But it was pointless for me to show you that because I just wanted you to get a feel for one way of doing it. This course is going to be kind of restrictive in that way because in a real computer programming course, the way they do it is they show you some process they want to have done. And then they'll give you 20 problems and you'll have to solve that thing over and over and over again in different ways to get experience doing it. We're not doing that because I don't expect you to be able to do that. What I think we should concentrate on in this course, because it's not a computer science course, programming course, is here are some tools that are just like logic tools, and there's only a handful of them, and you just have to rearrange them to get what you want, put your own names of stuff in there, and that's all you have to do. It's quite an easy process, and you can get a lot out of that. You can get all kinds of things out of that. You'll see, by the end of this course, you'll see that you can do a lot with it. And so, a lot of times the programs I show you here are very, very simple, and by the way, don't ever trust what I do on the board, because unless you guys are keeping track of me and stuff and yell, no, that's wrong or something, I missed something. It's hard for a person to see their own mistakes. I want to drop that in right now. If your program doesn't work, and you send it to me, and I make a correction on it, I say, okay, you should do this, you should do that. Pay attention to the fact of the mistake you made, because you will make that same mistake over and over again. All your programming history, you'll do it again and again. Once you learn your own mistakes, you become a much better programmer. Because immediately when something doesn't work, you say, well, have I done the old blunder? And you look there, and there it is, right before your eyes. After a while, you beat the mistakes you make. But in the beginning, you should always pay attention to what you did wrong and be sure that you don't do that again later. Because sometimes you have a program, and you run it, and you change it, and you run it over and over and over again. It's very frustrating to have a program that doesn't run. So then you send it off to somebody else, and they look at it with a different view, because they're not you. They say, oh yeah, that's that thing right there. That happens to me too. I mean, I can debug programs really well, but there are times when I come up against a program and I'll show it to one of my friends and say, yeah, it's right there. And you just, immediately they see it because they don't have the same blocks as you do. But remember that. You will make the same mistakes over and over again. And if you can't solve a problem, don't feel frustrated. Just let someone else take a look at it and see what they can do. Someone that has some experience, and they'll figure it out for you. Likely, between the two of you, you work it out. Okay, so the first thing I want to do is I'm going to hold off on the corrective program, the one that would correct the thing we did last time, because it's a long program, and I want to be sure that before I do that, that I introduce you to the keystrokes, how keystrokes work, okay? To begin with, the program called basic.js, which is an include file for the mouse things we were doing, it's the very same one that has the keystroke information. It does the same thing. It does proximity, it does what is your mouse down, up, drag, move, it does that. And it also says, if you hit a key, what letter did you hit on the keyboard, okay? Now, there are programs that, without you doing that, as you know yourself, if you put your cursor into one of those little boxes we have and you start typing, it'll go right in there. So obviously the programs listen to your keys, right? That's what they do. But when you put basic in, all of a sudden it doesn't listen to your keys anymore. Now you have total control over the keyboard. In other words, the keyboard doesn't do anything unless you tell it to do it. There are a few keys that are exception to that, because otherwise you might get locked into a program and never get out. But all of the normal keys that you would hit, even the arrow keys and whatever, semicolons, anything, all those keys you have control over. So when someone hits a key, you can immediately say, what key did they hit? It'll come to you and say, someone hit a key, and you say, what key did they hit? You can do that. And then, based on whatever key they hit, you can do whatever you want to do. Okay? So we have some programs here that actually take the input from the keyboard and do things. They move stuff around, they do all different things. But the first thing I want to do is I want to introduce you to the most basic of all possible keyboard programs, which is the one that actually allows you to grab a key and say, what is this key? Now, I don't think in the earlier programs, I don't think we've talked about this command before. There's a command called an alert command. It's in JavaScript. Okay? What alert does is it throws up a little box on your screen, and it puts anything in that box that you want to put. So for example, if I said alert, this is in JavaScript now, if I said alert hello, like that, like so, and the program has this in it, when it hit this structure right here, on my screen, this is my screen right here, a little box would pop up right here with the word hello on it. That's what would happen. When it hits that alert key, that's what it does, it puts it up there. If you have a variable that contains information, like for example, supposing you have a variable x and you want to see what x is, you put x in there, and whatever x's value is will appear up there. So what alert does is simply like a quick printout. It's not normally used for people just doing normal programs. Most commonplace an alert is used is if someone makes a technical mistake, does something that you don't allow the program to do, then what you do as a programmer, you set it up so that if they hit that mistake, you throw an alert, say, oh, you can't do that, or something. You'll say something to them. In other words, give them some guidance. So, for example, supposing you say, answer yes or no, and they put down maybe. Then you can have a thing that says, only yes or no, and go back up and do it again. So in other words, it would basically reprimand them for being clowns. So being administrators or whatever. So there it is. That alert key is something that you guys should know about. Okay. So now I'm going to write this program. What this program is going to do is very simple. It's going to allow you to listen to the keyboard to hear what they say. When they hit a key, what it's going to do is it's going to come up and it's going to tell you the numerical value of that key. Every key has a numerical value, which has nothing to do with the letter itself. Like 65 is A, 66 is B, 67 is C. Each one of these things has a value. So you don't know those values. So this program is going to do two things at once. It's in our today's program list, by the way. It's the first one of today's list. What it will do for you is when you run this program, if you hit a letter, it'll show you what the value of that letter is. So if I hit the letter A, it'll show you 65. That's its value, and so forth. So that's what this program does. And this is the program right here. So I'm going to show you how it works and show you what you would have to do to write such a program. Okay. So start off with it's HTML. And it has to have the script length. soon.
Is this how autocorrect got invented?
You need one of those for the board. Big long line, it's kind of a pain, but it gives you so much. It saves you so much coding. It's worth putting it in. It's worth adding it. The actual, I have a quote mark. Sorry about that. Quote mark right here. Do not forget your quote marks, or you'll be sorry. It won't work. Even some of this little zap will cause you trouble. Okay, as I probably said to you before, programs are very much like passwords. If you miss one letter, the password doesn't work, the program doesn't work. It's very, very common for that to happen. One letter, one number, one instruction, anything will blow off. Sometimes it doesn't affect it. Occasionally that happens, if you make a mistake and it doesn't affect it. But most of the time, when your program is driving you crazy and you pull all your hair out and you don't know what left to do except jump off the reading building, that's because you left out a semicolon or some simple little thing. So you got to be careful of all the quote marks, like the quote marks in the home assignment, for example. That was, I always watch out for that stuff. Okay, so now what I did is I have this thing in, and this thing will now listen to my keyboard. Okay, so I'm ready. So the first thing I want to do is put this guy in. Function. I'll explain these after I get them going here. Function. The function is called key hit. That's the magic word. It has to be called this. And you don't need to put anything inside the parentheses. Just be sure you put the parentheses there. Okay, so what happens is, when I hit a key, as soon as the program sees BASIC, it knows that I am capturing the keys. So it knows that I need to know what the keys are. And what it does is, when you hit a key, this thing sees that and it says, oh, okay, I know the key you hit. And then it jumps right straight down to this right here, to key hit, to your function called key hit. That's where it gives you the information that you're looking for. Okay, so first it goes to key hit. And then inside key hit, I'm going to say an alert here. That's all I'm going to do is alert you to what's there, what it hit. It's called keystroke. Key, all lowercase by the way. Stroke is an underscore right there. Stroke. That's it. And that's the function. That's how the function works. Basically, you hit a key, it sees the key, it jumps to here, and that contains the actual key, the numerical value of the key. Not the key itself, but the numerical value of it. So I'll show you how to use the program in a minute, but basically you get that. Okay, we got a script. Head. Body. Style. Text align. I always do this. It's not necessary, but I like to have my stuff in the middle. It makes it kind of centering stuff. That semicolon is optional. The very one at the very end is optional. Okay, it won't hurt. Be sure you put it inside the quotes, or if you put it there, be sure you put it there. Because it uses, between commands, it uses a semicolon. So you would normally have it if you had 3 or 4 commands, you would do that. We only have 1 command here, just a text align. So we don't really need it, but I put it there anyway. Okay. Whoops, don't need that. Say press any key. All it's going to do is say press a key, see what happens.
So would a program like this be used, say for example, when the computer goes into screensaver mode and you tap the spacebar and a key to wake it from that mode? Is this like where something like this would be used? like, would a program like that, or a function like this be used, say for example, to wake a computer that has gone into screensaver mode, where you like hit a key on the keyboard?
Screensaver stuff like that, those guys are, that's an operating system working there.
But it's not.
You have to go into the operating system or tap it somehow, and these things don't talk to stuff.
Okay, because I thought the press any key made me wonder.
Yeah, no, you don't have access to that stuff. You do, but you have to do weird stuff to do it. Press any key, blah, 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 end of story. /body, /HTML, /HTML. It's a slash right there, believe it or not. Okay, there it is. That's the whole program. Not much there, is it? It's just that simple. Essentially, once you put this line in right here, it is now open for business. It's waiting for you to hit a key. If you want to hit a key. If you don't hit a key, it won't do anything for us. When you hit a key, what it does is, it comes down to here. And then what it does is, this is the number of the key. It tells you what number it is. I'm taking this number and putting it out on the screen. So basically, if I hit like the letter A, for example, a box would come up and it would say you hit 65 or something. That's what it would do. It would give you the number of the thing. Okay? Now, you have to be a little careful in this. If you ever want to get into it more, you should look up the numerical value of keys of online. Look up the numerical value of keys. You're going to find out that there's two sets of numbers. There's different numbers. They have different systems. The alerts, the JavaScript works in this system right here. It's easy to use. I could have made it differently, but I made it this way to catch it this way. Because the advantage of this way is that if you hit any key on the keyboard, it will give you a number. However, if you hold the shift down and hit a B, it'll give you, if you hit the shift, it'll give you a number, and then when you hit the B, it'll give you another number. See, there are other systems where you could hold the shift and hit something and it would give you a number for the uppercase B or whatever it is. This one won't do that. This one gives you just straight out. Whatever key you hit, it takes it. No matter if it's a space bar, a return, no matter what it is, it just gives you the number. And the reason why is because I wanted it to be able to capture all those weird characters. Because we use the weird characters. We use the arrows, for example. We want to be sure we can catch that for what it's worth. And so, there it is. This is the program, and all it does is just that. It doesn't sound very much. But, for example, suppose you want to write a program and you want to have people type in a S for stop. You want to have the letter S be stop, okay? Well, first thing you have to do is you have to find out what the letter S is, what its value is. So what you do is you run this program. It's the first program in the set we have, and you hit the letter S, and it comes out with a number, and that number is the letter S. So in your program, you would know that this thing coming in, if it's the letter S, it would be that number. So you say, well, if the keystroke equals that number, I've got S. And then you do whatever you want to do. It's a simple if statement. Okay, yeah.
So would something like this be used as like a keyboard shortcut command? Like, hit this key to do this? Like on a Mac, like Control-C is copy and Control-V is paste?
You couldn't use it for that because if you hit Control, it'll give you a number. You can't use it for that.
And also,
any key you hit, it will immediately see it. This is not the number system that actually allows you to see upper and lower case. It only allows you to see what keys you get.
And what I was also curious is you have like alert and then key underscore stroke. If you were actually writing it out, in the case of like the letter S, would you have alert and then just the letter S in parentheses? That case?
No, you wouldn't do it.
Okay.
This contains.
It does actually contain that word. Okay.
Yeah, that number is what it contains. Yeah. Okay. So can I get rid of that? You guys on that? You realize how that works? Okay. So that's a simple. That's all it really does. It's kind of cool. It just gives a set. So now, basic now gives you the 4 mouse control instructions, and it also gives you key instruction, and it gives you proximity. It gives you all those things, which are kind of handy in programs because you want to ask people questions and you want them to do different things. The most common key I hit, by the way, is the space bar. I have them say, go to a different thing, hit the space bar, because it's so easy to hit. They don't have to look for it or anything, go bam. And so if you're going to go through some kind of site, you say bam, 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 just go through that, hit the space bar, it does it. So it just looks for that value, whatever it is. It's like 80 something, whatever. Okay, so next case. That takes care of that program. Let's write a program that Let's write a program that will navigate an object around the screen. In other words, what we're going to do is, if we hit the left arrow, the right arrow, the object will go doot, 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 like that. If we hit the left arrow, it'll go doot, 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 like that. Down arrow, it'll go doot, doot, doot. Up arrow, doot, doot, doot. So in other words, you can control the location of the object by just hitting these arrows. The program we did last time, using the mouse, was equivalent to this, except for the problem was it had some technical errors in it that it doesn't have online. If you look at that program online, you'll see all whatever it's supposed to be. But I'm going to write this one correctly so you'll be able to see, if you're using the keyboard to move something around the screen, here's how you do it. It's an easy breezy way. And it's very handy. It's kind of handy to do. Okay, so first of all, here's your screen. And you have some kind of an object, like a circle or something. Whatever, you have something. It's a picture. It's an image of some kind. And basically, what you want to do, don't forget with images now, let's say the image is, the upper left-hand corner is the actual location of the image. It's not the middle of it, it's the upper left-hand side. So for example, let me ask you from our previous class, if you knew that this guy right here was 150 by 150, that's how big it was, 150 pixels by 150 pixels, and its location was, right here was 500, 500. That's the x and that's the y. If that's this point right here, what would the midpoint be? What would the coordinates of the midpoint be? Think before you yell.
525, 525.
5 what?
525, 500.
575?
What?
575?
575. Yeah, there's 150, half of that 75. There's 150, half of that 75. So therefore this guy right here is 575.
For some reason I thought you wrote 15 right there and those were slashes.
And so that's actually the point we're interested in, because we want to know how close are we to that point right there. That's always the question, okay? But in our particular case, right now, we don't need that because we're not using the mouse. We're not going to go in and hit that thing. So we don't care about that. All we care about is the fact that this thing is at 500, 500. That's it. That's all we care about. And here's what happens. This is 500, 500. Now what I want to do is, I want to hit the right arrow, and if I hit the right arrow, what it's going to do is it's going to make this guy here move in this direction. If I hit the left arrow, it's going to move in this direction. If I hit the down this way, and the up this way. So what happens is if I hit an arrow, whichever one I hit, I look at the number and I say, well, if I hit that arrow, move it in that direction, whichever arrow is that direction. So if I hit the right arrow, move the thing in the right direction. How do you do that? You do that because you set this thing at 500, 500. You created it in that position. And what you simply do is you simply add something to it to move it. That's all. Okay? And that's what I'm going to show you how to do right now. Is how do you control the location of an object on the screen without a mouse or the key or anything? How do you move this picture around? How do you say, where am I and where do you want to put me? Okay? This says, where am I? When we set the thing up originally, that says, where am I? I'm going to show you how to write that. So, down here, I'm going to try to fit this all in. I'm going to write a little bit higher, see what happens. Write /script. I'm going to screw this all up now, watch. /head. Like so. Now, what we want to do is, we want to, I don't need as much space really. What we want to do is we want to create the object someplace, say body. And I don't care, I don't have to center anything because I'm going to tell it specifically what it be. So I say I want to create an image, and I want the source of that image to be a button or some picture, whatever it is. Okay, there it is, dot ping. Because I'm making it a ping simply because if it is a round thing, I want to get rid of its surrounding stuff around it. Okay, so it's got pictures ping, and I want it to have a style. And, oh, I'm sorry, one more thing before I do that. I'm going to say I want it to have an ID, and I'm going to call it spot. I'm giving it the name spot, okay? That's the name I'm giving this picture in my program, ID is spot. Okay, then I say that I want the style to be, I'm going to give it all the things I need, so I need a position. colon absolute. That means I'm going to put it someplace, and I want it to be in that spot. Absolute semicolon. I want its left side colon to be at 500, and I want its top to be at 500, right there, and I want its width to be 150. 150. The reason why I did that 150 is because I want it to be 150 wide and 150 tall. That's so I'll know that, you know, I know where the middle is if I need that for any reason. I don't have to need it, but should I need it, I've got it. So there it is. I put the picture down. It's at 500, 500. It's 150 by 150. That's all I've done with this line right here. I gave it a name spot. Okay, so first thing you do is I have to keep track of where this picture is in my JavaScript program. This is a peculiar thing. JavaScript and HTML communicate with each other very poorly. It's not the best communication you ever saw. There are certain things, certain times JavaScript can talk to HTML and HTML can talk to JavaScript. We've already done that with some calls to the functions. But some things just don't work. It's because of the way, when they made JavaScript, JavaScript subscribes to the rules of programming languages, and HTML was already created and it had its own set of rules. So for example, let's take something simple like using in body we say text align. We have a hyphen between it, right? Text align is now text align means this is contains center. We're going to put the word center in here. So it's a variable. It says text hyphen align. The trouble is if you put text align up here, JavaScript sees that as a subtraction sign. So you can't do it. So you see they had a conflict between the way they wrote things down here and the way we were writing things up here. So you always gotta realize you can't use exactly the same names as they use down here up in your program. Okay, and that's the reason why, for example, we have to say dot value for stuff, because it's a characteristic of the thing. So here's what happens. To make a long story short, this thing right here will create the information we need, but I am going to make two variables for top and width. For left and top up here. Right up here, I'm going to say variable x spot equals 500. I think I used that variable. I just called it x. Okay, I called it x. X equals 500, and variable y equals 500. Those are exactly the same numbers as these two numbers are here. I did that on purpose. Okay, and I'll show you as we write the program. I'll show you what complications come up, so you'll see why you have to do that. In other words, what they have to do is, if I'm going to set the position of this thing to start with, JavaScript has to know immediately where that position is to start off with. It has to also know. So whatever numbers you put in for left and top, they have to be right here. That's the left and that's the top. They're the same number. They're going to be the same. Okay? Because JavaScript's going to operate on these numbers and then pass the answer down to them. So in other words, if it subtracts something from 500, that better have been 500 in the first place because you're going to move it to that new position. So they're going to be exactly the same as these two numbers down here. So that's what I'm doing. I'm setting them up like that. Now I create this function. And the function has got to be called key hit because someone hit a key. They hit the left key, the right key, the up key, or the down key. They hit some key, all lowercase there. And so now what we have, I'm going to put this right here, which should be right here. It does the same thing. Okay, so what I want to do is I want to say if keystroke equals, they have two equal signs, right? Equals 40. It turns out, let's see I'll write this down for you, see if I have them. This is 40 down here. The down key, I tested it, was 40. This is 39 right here. This is 38 up here. This is 37 over here. So in other words, These are what the arrow key values. I ran it through the previous program to find out what they were, and those are the numbers I came up with. So I know 40 is down 39, 38, 37. Now, so if I say if the key is 40, that means they hit this arrow right here. That's true. So if they hit that arrow, what am I doing here? Yeah, they hit that arrow. What I want to do is I got to remember to put this over down here. So I started up there. It's got to be down here. It's got to end down here. Okay, so then I say as well, what's 40 I want to do is, and this is a new instruction for you. You haven't seen this before. I'm going to show it to you. X Y. Okay, Y. Y plus equals 2. Let me write the instruction, then I'll tell you what I'm doing here. Spot dot style dot top equals Y. Okay, style equals Y. Okay, now here's the whole thing, and it's got a lot of stuff in it, so I'll tell you all the different things. To begin with, after it hits key, I say, well, did you hit key 40? Did you hit 40? And if they did, that means you want to go downward, okay? So it turns out that the way the screen works is Y is greater as you go downward. It starts at the 0 at the top, and then it keeps going higher as you go downward. So in other words, if you want to move positively, you have to add something to it to make it go down. That's how you make it go down, okay? So I decided I want to move it 2 pixels. And now this funny little thing right here, it looks really weird, that structure. Let me show you what that structure really means. It means let Y equal Y plus 2. That's all you're doing, is you're saying, I have Y, I add 2 to it, and I put it in Y. That does it all in one little deal right there. It's very cute. All programming languages do it. Basically what you do is you take how much do you want to add to Y, and you put it right here, and then you put plus equals between them, and that does it for you. If I put a minus sign there, what it'll do is it'll subtract 2 from Y. So Y becomes 2 less. So it becomes 2 more, 2 less. It's a little shortcut that does this right here. Like the subtraction would look like this, equals Y minus 2. So if I wrote this, that would mean this down here would say take Y away from it, and then set it equal to Y. So that's what you're doing. In this case we want to add. We want to add 2 to Y. So in other words, originally Y was at 500. When I add 2 to it, it's going to be 502. Because it's getting bigger, right, as it goes down. So what I'm doing is, I'm saying, well, if you hit the down arrow, add 2 to where Y is. And that's what I did, I add 2 to where Y is, up here. But now I have to tell this line where Y is. This is the one that has to know in order to move it, the picture. It controls the picture. So what you do is, you have this special thing. It looks like this. It says, look at the object called spot, which is this right here. Look in its style sheet, that's what that dot does. Look in its style sheet, which is right here. And look for the word top, which is right here, and set that equal to the new Y you just did, 502. Set that equal to 502, and that will set that equal to 502, and immediately when it changes, the picture will go ba-doop, just like that. It does it automatically. In other words, you do the arithmetic, and then you tell HTML what to do. You say, move that picture down. And that's what it does, it moves the picture down. You also have another command. You say, well, if keystroke. Let's see if you guys can follow me here. See if you can see what I got to do. Someone besides you. someone else. Give someone else a chance here. So I said 38. So I said 38. So I said 38. Now, if I say 38, which way is it going to go? Up. Because 38 is the up key. So, if I want to do the same thing as I did here, obviously if you go up, you go minus, right? You have to go minus. If I want to go 2 pixels down towards the top, what would I put here for Y? Y what?
Minus 2.
There it is. Minus equals 2. That moves it up way. Moves it up 2 pixels. Okay? Now that I've done that, now I want to set that Y equal to this right here. So don't forget, the Y goes into here. So I say spot. What will I put here? Spot dot style dot what though? This time I'm going the same direction, right?
Top bottom.
What? Yes? Does that all make sense? So in other words, I have 2 strokes now. If I hit 40, it'll go boop, boop. If I hit 38, it'll go boop, boop, like that. So depending which arrow I hit. Now, I'm going to get rid of this right here. We don't need this anymore right here. So what I'm going to say is now, what if the key they hit, in this case, stroke. Now let's see if we can figure this one out without ever talking much about it. Equals. In this case, it would be number 37. 37. Over here. Now what would I do if it's 37?
X.
X. I have to change the X, right? Because it's the X value that's related to the direction this way. So you say X, what do you say about it? 37 would be that way, which is negative, right? Agreed? I put an equal? I put an equal there, huh? Equals 2. There we go. So in other words, what you're saying is if you hit that key, then you go that way. And you say spot. Now this is what's going to be tricky. Tell me what this is going to be. Style. What? Left. Who said that? But genius said that. Both of you, okay. Where's my grade book? Telling you A's in here. Left. Gotcha. Left. And equals X. My writing's awful, but you get the idea. And there's going to be one more. This is right here. Key. Underline stroke.
Equals 39.
39, which is which way?
X plus equals 2. Spot dot style dot right equals X semicolon close
No,
bracket.
not right. This is still the same variable right here.
Oh, because it's just like you're subtracting.
That's the
it
same
out.
variable, yeah. That's the same variable.
Okay, never mind.
That's why I use that down, you use that top, yeah, that's why. It's only one thing, you only have top and
Because you can be like plus negative 2 is like subtracting 2. Okay, now I get it.
there it is. And that's it, that program, now I have to do is just pull all stuff /body, so forth, /HTML. And I also, I cut out some steps right in here. Cut out the /script, head. Okay, I pulled those out. Did they pull out anything else? Oh, and I pulled out the end of this. This right here has to be. So as I opened up this function right here, I have to close it. Okay, I think that'll be about it. That should do it. Okay, so what this program does is kind of cool. This program means if you have this object, you can start hitting those keys, the arrow up and the arrow down, the arrow left, right, and you'll watch the object go, it'll go 2 pixels every time you hit it. And by the way, it turns out, unlike the mouse, which is kind of a deadhead object, when you hit the mouse down, it does that. It says mouse down, and it doesn't do anything else. The keys are totally different. If you hit a key down, you hold it, it goes ba-doop-ba-doop-ba-doop-ba-doop. So if you hold it, the thing will go right across the screen. Well, that's what's nice about the keys. It gives you a continuous re-hitting of the thing, okay? So that's very useful. That's the reason why sometimes it's nice to use a mouse, sometimes it's nice to use the keys, depending on what you're trying to accomplish. And there it is. That program should work.
Would something like this be used in like a video game where your guy is walking around by hitting the arrows?
Yeah, we're getting close to the video game state right now. Yeah, this is close to that stuff. Okay, so what do you think? Are you guys satisfactory? Does it make sense? Does it make kind of sense to you? And these 2 programs, or something very close to them, are actually on the website. Okay. Just for fun, I wrote a different program, which here's what it does. It has, for example, you got 4 colors. You got a spot, and it can be red, green, blue, or yellow. You can have any of 4 different colors. And this program, all this program does is if I hit R, the spot turns red. If I hit G, the spot turns green. If I hit Y, it turns yellow. So it's not much different than what we're doing here, except that we're using different letters and you're getting a different result. I want to show you how the possibilities. There's also a new idea in this. Just like there was a new idea right here that we talked about last time, but didn't get into it in detail. There's a new idea, and also this thing right here, which I never told you about before, that thing there. This other idea is quite interesting. It turns out you can put a picture on the screen and you can make its opacity 0. You can make it completely invisible. Okay? Or you can make it completely visible by making it 1, the opacity it has. Opaque means you can't see through something. So if it's 1, it's maxed out, you can see it clearly. If it's 0, you can see right through it, you can't see it. It's possible, down in here when we set up a picture, it's possible to set the opacity of a picture at 0 or 1. And then, in JavaScript, we can turn it back onto 1 and turn it to 0. So that we can make it visible or invisible. We can make pictures come or go. Even though they're all there, we can't see them unless JavaScript, if we set them at 0, JavaScript will say turn it onto 1 or not. Okay? So you can see how that would work. I put 4 little pictures in one spot. They're all exactly the same shape, except one is yellow, red, green, and blue. There's 4 of them. And all of them are visible except one of them. And so what I simply say is, if I hit R, the spot turns red. That means green, blue, and yellow turns opaque, invisible. Okay, and this is 1. The only red is opaque. If I hit G, then the little green picture turns up, and the other guys are all made invisible with zeros. So that's all this is going to do. So basically what this program does is, whatever letter I hit will tell me which one I want to see, and it will make the others invisible. Okay, kind of a simple program, but it's got a good thing to it because it uses the new stuff we have. Plus, it does something different that you might see that's useful for other things. Sometimes you get locked down to stuff. You know, this is a more complicated program. This other one I'm going to do right now is not complicated, but it's wordy because if you turn on one color, you have to be sure that the other 3 are off. So you actually have to say, turn these other guys all off, which is kind of a nuisance. But it looks like a lot of writing, but it's actually what you have to do to make stuff happen. Okay, to start off with, let me put these pictures down here. There's going to be 4 pictures down here. Down the body is going to be 4 pictures, and they're going to look like this. I'm going to just do one, and we'll assume that all the rest look like this. The way I did it was, oh yeah, it's image.
So in this case, are you just setting it up at one step at a time?
Okay. What did you say?
Are you just setting it up one step at a time where you started?
Yeah, I'm not going to do the whole program. I'm just going to set it so you can see how it works. Okay, so right here, what you have is, I put a red ball on the screen. It's actually, the red ball ping is just a red ball, that's all it is. So here I do, I put it on the screen, and I put it at location 800, 300. So it's way over there up here, it's right here someplace. That's a red ball, it's red now. And its opacity is 1, so you can see it. Had I put a 0 right here, in opacity, you wouldn't see it, you'd see nothing. Even though it's there, you don't see it. But by telling it its opacity is 1, I bring it to life. Okay? And there it is right there. And it's colored, the color of the ball, the image is red, so therefore that's red right there. It's a red color. Okay, now, what I have to do is I have to create 4 of these things. I have to put all 4 of them in the same position. The red has to be exactly the same ball, same color, different colors, but same shape and everything. I put them all there. Source, I have a green ball and a yellow ball and so forth. I put all these here, put them in exactly the same spot. Everything's exactly the same except this. what I do is I make them 0. So in other words, the other 3 is 0, and this one's 1. So therefore, all you see is that one. The other 3 guys are invisible. Okay? Then what I do is I have to tell people what to do. So I tell them to hit the letter red, green, blue, or yellow. I say hit one of those keys, okay, and it will change the color. So what happens is they have basic up here, and they have a function. And that function is key. I always forget it myself, even though I invented it. So it's hard to believe that it actually the way it was key it. I think because I've gone through so many different renditions of this thing over time, I forget which is which. But there is key is what this one is. Okay, then I say, okay, I'm going to ask a question. I say, if, oh, by the way, let me give you the colors. Let me give you the colors down here. Red is 82. I looked it up. Green is 71. Blue is 66.
Are these just colored numbers?
And yellow is 89. Those are the colors right there. Those are the letters R, G, B, and Y. And you can figure it out by the way. If you know that A is 65, all you have to do is keep adding 1. B is 66. C is 67. That's how it kind of works. Okay. So next question is, so I say, well, I want to know what color the thing. So I say, well, if now I turned on the red one right away. So the red one is on now. Red ball's on, okay? So I say, well, if what? Let's look at the right program here. So I used the 82 first. That's red, okay. If the keystroke equals 82, that would be red, right? So if red is the one I hit, if red is the color I hit, what I want to do immediately is I want to make red style opacity 1. I want to be able to see it. So I say, okay, if I hit the red one, what I do is I say red dot style dot opacity equals 1. There it is. Notice something else here. This is for your own consumption, so you don't get mixed up on things. Up in here, what we say is I say this equals 1. Down here I say opacity colon 1. You know these equal signs and you use colons. Sometimes I've had people program and they make a mistake in here. Don't make that mistake. This guy here, the equal sign's right there. All the rest of these guys are colons and semicolons. That's HTML, CSS language. This one right here requires you to do it with an equal sign. So what I've done is I said the rest of, so naturally what I can do is I can say the other guys, like green, for example, green dot style dot opacity equals 0, and yellow dot style dot opacity equals 0, and blue dot style.
So by having your opacity equal 0, you're turning those colors off, if you will, right?
What?
By having your opacity set to 0, you're like disabling those colors.
You can't see anything.
You're turning them off.
You're turning the visibility off. You know. Opacity means how much can you see it. If you put 0.5, for example, opacity is 0.5, it'll be translucent, transparent. You can see partway through a translucent. So you can change, what is it between 0 and 1? Any number between 0 and 1, like right in here, will actually make it slightly, you make things fade away, for example, by having it loop through something.
Could you also have like blue and yellow with a half opacity to make it green?
Yeah, and I think that would give you the reading. I think it would give you correct. Green and blue would give you yellow or something like that, or some such thing.
Yeah,
I don't know what the mix is for the, yeah, that would do, I think it would work. Okay, so therefore, if it's 82, that's what you do, you turn it right on. If the keystroke, I'm not going to write all these down. Whoa, I'm not going to write any of them down, I guess. If key stroke equals the next number, which is 71, what you want to do then is you say green right? Because green is 71. Dot style,
Dot opacity
dot opacity
equals 1.
equals 1. And then you make all the other ones. You do the same thing he said, get rid of red, yellow, and blue. You make them all 0. So in other words, but you have to have, you have four images down here, and you have to have 4 different if statements for each of the different possibilities. And you simply turn one on and the other 3 off.
You said that any number between 1 and 0 will make the opacity like that percent. Should you write that in decimal form or fractional
Yes,
form?
decimal, 0.1, 0.2, 0.3, yeah, it accepts it.
Since you put like, so for first one, red dot style dot opacity equals 1, and then the other ones you put 0.
Yes.
Since you have a set order there, does it
No.
matter if you change order for the next one?
No, it happens so instantly.
Okay.
It happens pretty quick. So this thing, once this thing is in the machine, it's done. Otherwise, I can imagine something if you had something really with 600 colors. There might be a slight something or other there, but you know, it doesn't make a difference. So what you have now is you have 4 different circles, and you have a way of, depending on what letter you hit, you're going to have that circle turn on and the other ones turn off by just simply by changing their opacity. Okay. Not too bad, is it? You guys don't be afraid to experiment with this stuff. You can play with it. You can play with your machine and figure out how it works. And ideas. Some of the ideas in here will come back to us later. We're going to be using them again. Opacity is one we use a lot later on, and we'll use it with video, which, by the way, is next week. I'm going to start covering video stuff. So you'll see that these things are very, very handy to have in their different manifestations. The program I didn't do was this one here. No, I did the navigation. I did them all. I actually did all 3 of them, so we're all set. That's it. I'm going to probably resort to going online here and showing you these 3 programs again and talk about them. I made a giant mistake today. I didn't bring my reading glasses, so at least I can see you. I can't see what I'm writing, but I can see you anyway. So I'm not going to be able to do very much on the computer. I'll just blindly go through it. You can scream and yell, you know, oh, not that one, all that stuff. But that's it. So you can either stay, go, or whatever you want. I'm going to go to the computer.
Now, since we're going to start videos soon, did you find another program other than that Screen-O-Matic to capture them?
The Screen-O-Matic works. All you have to do is it will, when you run it the first time, it puts a little blue circle on the bottom there, and that means it's working. They just don't say it anymore. I don't know why.
Okay.
I never know. Since people started using the cloud, I never know whether they insert just a little piece of their program in to get a hold of them, or whether it's the whole program, or whether it's just who knows what it is. You know, I never looked to see what they give us, but they gave us something. So if you press that thing, it'll come up.
Okay.
So we don't care how it works really. It does pretty much work the same.
Do you think the lab computers would actually have that installed? Because same situation I had with XNView I was telling you about?
I don't know, ask them. I'm not
I
sure.
would just ask the lab attendant
Yeah.
when they're done.
Yeah. Because I don't think they have video.